Hi guys! Magandang araw po sa inyong lahat. This is Miss Sean from Keep It Up with Sean. Ready na ba kayo sa inyong board exam? Ako hindi pa. But then I am trying my best to prepare all presentation na sana makatulong sa inyo. This topic, we are going to talk about soil pH and lime requirement. And before we are going to discuss this topic, let me thank all of you for all the messages, at ng mga comments, and corrections, and dahil sa inyo, I can still improve my presentation at makorek ko yung mga mali ko na nagawa ko sa presentation ko. Kasi ang dami kong inisip guys, ang dami kong kinopy and paste, and minsan hindi ko na check lahat ng mga questions, and I'm very glad na dahil sa inyo, na-correct ko yung mga mali na yon. Hopefully, I can still improve the next presentation. Hindi na to makakahabol yung mga ginawa ko for the board exam in 2 weeks. But I will try my best na for next year, sana makapag-prepare ako ng mas maganda at mas comprehensive na presentation. Ma-improve ko yung mga question and answers portion para mas madali nyo siyang maintindihan at saka mas ma-explain ko yung bakit ganun yung answer as suggested by one of our readers, one of our viewers. Maraming salamat. And yun. So, hindi ko na ma-cover lahat ng mga topics kasi na kulang na tayo sa time. But then, this topic is about soil pH and the lime requirement. For the VAGE method, guys, I don't know. I haven't encountered those topic during my college days. Yung isa ko lang friend na from CMU yung explain sa akin. And for this presentation, during the preparation of this lecture review, nag-research din ako, and then I studied also para naman maisama ko siya sa presentation ko. So, I will try to make it easy for you and to explain it to you intensively. And also, so this is about soil pH and lime requirement. The next topic is all about fertilizers. So, hanggang doon na lang muna yung kaya ko ma-present. So, yun na lang yung coverage ko for these videos. And next year, I will try my best to prepare all materials ahead of time. So maraming salamat and thank you for subscribing to my channel and let me know kung meron kayo mga clarification at kung paano ako makatulong sa inyo. If you want to keep in touch with me, you can always send me a message via Facebook or Messenger. You just search the page Keep It Up with Sean, and you can always send me a message in case you want to ask something from me. So thank you very much and see you again on my next presentation. Bye! For today's lecture, we are going to discuss one of the chemical properties of the soil, and that is soil pH. What is soil pH? Soil pH stands for potential hydrogen. It refers to the acidity or alkalinity of the soil due to the relative concentration of hydrogen and hydroxide ions. It is one of the most important chemical properties of the soil because it affects the availability of nutrient elements in the soil as well as the microbial activities associated with soil fertility. That's why knowing your soil pH will give you a lot of information. It is the negative logarithm of the hydrogen ion concentration in the soil. And the formula for this is minus log of the hydrogen, where the hydrogen is the concentration of hydrogen in moles per liter. It covers a range of 0 to 14. So these are the pH values ranging from 0 to 14, and the pH value of 7 is neutral, like pure water, while values below 7 are acid, and above 7 are basic or alkaline. And each unit change in pH is associated with tenfold change in the hydrogen concentration. As pH increases, the hydrogen concentration decreases. When you say pH is low, that means acidic. pH is high, that means basic or alkaline. I have here sample problems. For example, you calculate the pH of a soil solution with hydrogen concentration of 5.3 times 10 to the 5th. For the solution of this, it's just the minus logarithm of the concentration of hydrogen. So if you use your calculator, then you will get a value of 4.28 for that pH. And then I also have the second example. So it's the opposite. So you calculate the hydrogen ion concentration if the pH is 5.52. So the negative of the opposite of the log is antilog. So it's just antilog minus pH. So it will be, in this case, antilog minus 5.52. So it will be 3 times 10 to the negative 6 moles per liter, or 0.00050, and then 3 molar. Then this is the category of the soil pH. So I told you that when the pH is low, it means that the soil is acidic. Example, pH values below less than 4.5, it means they are extremely acid soils. And 4.5 to 5 is very strongly acid. 5.1 to 5.5 is strongly acid. 5.6 to 6 is moderately acid. 6.1 to 6.5 is slightly acid. And then we have the neutral, 6.6 to 7.3. And we have also the mild alkaline. So alkaline from 7.4 to 7.8. It is moderately alkaline if it's 7.9 to 8.4. Strongly alkaline if it's from 8.5 to 9. And very strongly alkaline if it's greater than 9.1 soil pH. So how are we going to imagine what is the pH? Based on this scale, so like for example, we have here a range of 0 to pH scale from 0 to 12, so that you can have an idea how does that pH looks like. So we have here 0, the battery acid, the acid in the battery. You remember there's an acid in the battery, so that is between 0 and 1, very, very acidic. Lemon juice, I'm sure you have already tasted lemon juice. Maasim siya, di ba? Very, very sour. And that's the acidity of 2. So can you imagine? If that is the acidity of your soil, then that soil should taste like lemon juice. You can compare it. And then 3 is vinegar. 4 is beer or coffee. It's also acidic. Between 5 and 6 is the natural rain. And then between, and here in 7, the pure water or milk. And 8 is around seawater. Diba? Kung nakainom na kayo ng tubig ng dagat, it's not sour, it's not maasim, but then maalat. So, seawater or baking soda has a pH scale of around 8. And we have 9 for the antacid tablets. We have 10 for the milk of magnesia, in between 10, 11. And then we have bleach, yung chlorine. It's a high pH, around 12. So those are the, how to imagine the pH values if you compare it. Yeah. And then we also have here the ranges found in soil. So we have here from below 4, we have acid sulfate soils. 4 to 5, from 3.5 to 6 is around forest soils. From 5, pH 5 to 7 are humid region arable soils. And we have the neutral. And from 7 to 8.5 is calcareous soils, and with a lot of limestone. And from 8.5 to 10.5 around sodic soils. So we have here the acids and the alkaline. So neutral, and then we have the alkaline. Then how do we determine soil pH? So before we go that, I told you that soil pH is very, very important, and it is the single most important chemical property of the soils, like soil texture is to the physical properties. Knowing the pH of your soil will quickly allow you to determine if the soil is suitable for plant growth and what nutrients will be most limiting. Later, we are going to discuss about that. And to measure the soil pH, we need pH meter. Neutral solutions, when you have enough equal concentration of hydronium ions, the hydrogen, the hydroxide ions, and the water. So that's neutral. So equal yung kanyang values or yung kanyang concentration. But then when you have slightly acidic solution, makikita nyo dyan the hydronium ions, which are red, are higher, greater compared to the hydroxide ions. So there will be more hydrogen in the solution. For this case, it's slightly acidic solution. So acid solutions are when pH is less than 7. Alkaline solutions are when pH is greater than 7. An acid can be defined as a proton donor, a chemical that increases the concentration of hydronium ions in the solution, while a base is a proton acceptor, a chemical that reduces the concentration of hydronium ions in the solution and increases the concentration of hydroxide ions. If the soil is acidic, it means that it has a lot of hydrogen ions in the solution. And if it's basic, then it has a lot of hydroxide ions in the solution. How are we going to determine the pH? So we have two methods here. We have colorimetric method, wherein we use litmus paper or organic dyes, but then it is less accurate. So when you use the litmus paper, for sure in high school we did it before. When the litmus paper turns from blue to red, it means to say that your solution is acidic. If your litmus paper from red turns to blue, then that means that your solution is alkaline or basic. Then we also have another method. The problem with the colorimetric method is you only know whether your solution is acidic or alkaline or basic, but then you don't really know how much. Is it slightly acidic, strongly acidic, or moderately acidic? You don't have any idea about that. That's why it is less accurate compared to the electrometric method, which uses the pH meter. So using the pH meter, it will give you an idea, the value, the correct value, and then you can confirm whether it's slightly, moderately, or strongly acidic or alkaline. Saan pa galing ang acidity ng lupa? Bakit nagiging acidic yung lupa? The hydrogen and aluminum cations are responsible for the soil acidity. Exchange of hydrogen is the main source of hydrogen at pH 6 and above. So pag ang lupa mo ay has a soil pH of 6 or higher, meaning ibig sabihin yan na maraming exchangeable hydrogen, which is the main source of hydrogen. Kaya nagiging acidic yung lupa. However, if your pH is 6 or below, aluminum is the main source of hydrogen due to the dissociation of aluminum from clay minerals. And aluminum becomes more soluble at lower pH. And remember that the plants doesn't need much of aluminum. We have the hydrogen and aluminum, those two. Pero bakit nga ba nagkakaroon ng maraming hydrogen at saka aluminum sa lupa? Saan galing siya? This is the reaction, how aluminum becomes the main source of hydrogen. It is because of these processes. So you see, when the aluminum reacts with water, aluminum dissociates and it gives extra hydrogen. So adding those hydrogen will give you more hydrogen in the soil through from the aluminum. So nagiging acidic yung lupa kasi you give more extra hydrogen to your solution from undergoing this reaction. But then, my question is, saan nga ba galing ang aluminum at saka hydrogen? One of that is long-term use of acidifying fertilizers. Pag matagal kang gumagamit ng acidifying fertilizers which are containing ammonium, like for example, ammonium sulfate, ammonium nitrate, ammonium phosphate, all fertilizers that contains ammonium, in the long run, if you use it frequently and matagal na ka nang gumagamit niyan, in the long run, through time, you will give a lot of hydrogen to your soil, which causes the acidity of your soil. Why? It's because of the nitrification process. Ano ba ang nitrification process? It is a microbial process by which reduced nitrogen compounds, primarily ammonia, are oxidized to nitrite and nitrate. So from ammonium, it reacts with oxygen and then it gives nitrate and then giving also additional hydrogen. And these are the two processes of this. So nitrification happens due to two different types of bacteria. So first, nitrosomonas carry out the first step, producing nitrite. And then the nitrite is then converted to nitrate by nitrobacter, giving now nitrate. It occurs very, very slowly because of the slow growth of the bacteria. And remember that these bacteria are autotrophics and they are needing carbon dioxide as their carbon source. So this process takes long time. So through build-up of your ammonium fertilizers, ammonium-containing fertilizers, it will undergo the process of nitrification in which they are going to release a lot of hydrogen, kaya nagiging acidic yung inyong lupa. Second is organic matter decomposition. Why? Because during the respiration, microorganisms also uses a lot of carbon dioxide for them to grow and for them to be able to function and to multiply. But then through that process, some of the hydrogens are being released and it gives an additional of hydrogen in the soil. So the fulvic, humic, and other inorganic acids are formed during organic matter decomposition and giving an extra hydrogen to the soil. So the production of carbon dioxide during organic matter decomposition is responsible for the lowering of pH of calcareous soils in submerged soils. Third sources of soil acidity is acid rain. For sure, nakarinig na kayo ng acid rain, but I haven't seen one. Luckily. How does acid rain form? Acid rain is caused by the burning of fossil fuels. It doesn't happen overnight, guys. So, pag matagal kang nagsusunog ng mga fossil fuels and also from the burning of oil, gas, and coal in power stations, lahat, mga factories, lahat, kung minsan nag-uuling, di ba? Pag nag-uuling tayo, ang dami-daming mga usok na-form. Those usok, those smokes contains a lot of gases. So may mga sulfur, other compounds which are being released there. So like for example, the burning of oil, gas, and coal in power station releases sulfuric dioxide into the atmosphere. And the burning oil and gasoline in motor vehicles put nitrogen oxides into the atmosphere. Yung mga tambucho, di ba? Sa mga cities, big cities wherein a lot of cars are there, releasing a lot of smokes. Those contributes to the chemicals that are found in the atmosphere. And these gases, like the sulfur dioxide, the nitrogen oxides, these gases mixes with water droplets in the atmosphere, creating weak solutions of nitric and sulfuric acids. And when this precipitation, when rain happens, of course, this solution fall as acid rain. So that is how acid rain is being formed. Now, in the other developed countries, they are very, very strict in emitting those gases into the atmosphere. So, mga tayo nagkakaroon ngayon ng electric cars, di ba? Para maiwasan yung paggamit ng fuels, para less yung mga gases na mapupunta sa atmosphere. So, this is the effect of acid rain, in which the carbon dioxide, carbonic acid dissociates. So the carbon dioxide reacts with water, forming carbonic acid, and then it dissociates, giving you 2 hydrogen. And pag marami ka na niyan na form sa, it will also give you additional hydrogen and it will cause an acid rain. So here you can find in the left side, there's pictures, the trees that are badly damaged by acid rain. And on the second picture, how acid rain affects stonework. So the picture on the left was taken in 1908, And the picture on the right was taken in 1968, so 50 years after, same monument, same rebulto, but then you can see that the structure is deformed because of the acids that is being affecting the formation, the sculpture. This is how acid rain forms. So you have here the sulfur dioxide reacts with hydroxide and then forming sulfuric acid, and then when it dissociates to sulfate, and it releases hydrogen. Same also for nitrous oxide, giving you like that, and then also additional source of hydrogen. Source of acidity in the soil is the uptake of basic cations by plants. Heavy cropping. So every time na nag-harvest tayo ng mga tanim from the field, we are also taking a lot of ions from the soil through the plants kasi a lot of the nutrients are being absorbed and translocated in the different plant parts. So the basic cations are sources of hydroxide to the soil solution. Pero since hinarvest natin yung tanim, the basic cations that are taken up by the plants no longer contribute hydroxide to the soil solution. The hydrogen ions are released to the soil solution. Heavy cropping removes basic cations and replaced by hydrogen ions from the roots. That's why, syempre, kung yung field mo ay puro ka lang harvest ang harvest, or remove ka lang ng remove ng mga crops without adding something there, later on, the soil will be depleted by all nutrients, and those nutrients that are removed are being replaced by hydrogen ions from the roots of the plants. That's why it's very suggested na we have to return some of the plant parts in the field. Another source of acidity is the leaching of basic cations. As basic cations are removed from the soil solution by leaching, they no longer contribute the hydroxide ions to neutralize the ever-increasing of hydrogen. So, pag palaging umuulan, nalileach down yung mga basic cations, so nawala yung potassium, nawala yung sodium, nawala yung magnesium, at saka calcium, don't contribute to the hydroxide and to neutralize, and nag-i-increase ngayon yung amount ng hydrogen in the soil, causing, again, another source of acidity. The sixth sources of acidity in the soil is through mineral weathering. Chemical weathering of rocks and minerals releases acids and supplies cations and anions. When acid and sulfur deposition are greater than this level, it will cause acidification in the area and resulting to some lakes that are even dangerous. So for example, in this case, this is a lake in Costa Rica. It has a pH level nearing 0, and it's a famous volcanic crater lake, has one of the highest acidity counts of any lake in the world. The sulfur are floating on the surface of this lake, produces a mesmerizing array of colors, from green and blues to bright yellows. Pero wag kayong maliligo dyan, guys, kasi it's very, very acidic. Another example of effect of mineral weathering is this. In the left side, you can find there the Kawah Agin, which you can find in Indonesia. It is a beautiful turquoise-colored lake and is the largest acidic crater lake on the planet. It has a pH level of 0.13, near that of an battery acid. Then, of course, we also have in Los Baños, Laguna, in Philippines, the mud spring, which is due to the volcanic heat from Mount Makiling. A mud spring is born where the clay mixes with water rich in sulfur. So you can always climb there. If you happen to be in UPLB, you can always go to forestry, but then it is not allowed to swim because it's too dangerous. There are three kinds of acidity. We have the active acidity, which is the hydrogen ion activity in the salt solution, and this is due to the hydrogen in the salt solution determined as pH. And then we also have exchangeable acidity, which is salt replaceable. This is associated with exchangeable aluminum and hydrogen ions in the parent material, and they take the place of beneficial cations. They replace the beneficial cations, and that's why it's called exchangeable acidity. And then we also have the residual or reserve acidity, wherein the hydrogen and aluminum ions bound to organic matter and clays and may free up cation exchange locations with liming. It may be 100 times greater acid input than the other pools. So ito yung pinakamadami mong makikita. And it measures the buffering capacity of the soil. How is the soil becomes acidic? So number one, we have there the humus and the clay colloids. Remember, in the ion exchange, we know that the colloids contains negative charges, and a lot of ions are being attracted there, especially the basic cations. We have the potassium, magnesium, calcium, and sodium. The positive ions, which are the cations. And then, aside from that, it also attracts other elements. So we have there the exchangeable cations, and there will be an addition of hydrogen ions from acid-forming processes. So, nagkakaroon siya ng addition. And also, there will also be coming from anions of acids like from nitrate, from sulfate, from carbonic acid. And sometimes, there will be an exchange of ions from, nagkakaroon ng exchange ng cations. So, some of the magnesium, potassium, calcium, or sodium will be replaced by hydrogen in the soil, which adds to the acidity of the soil. And some of these cations are leach, calcium, magnesium, potassium, and sodium, along with anions, in which hydrogen are being left, which again which contributes again to the acidity of the soil. These are the aluminum and hydrogen bound to clay surface of humus functional group. So those are all here. You can see here, we have the residual acidity coming from the aluminum and hydrogen bound on clay and humus. And then some of this, meron siyang reversible process, salt replaceable, exchangeable acidity. So we have here the aluminum hydroxide, and the hydrogen ions held near clay and humus surface. And then from that, it can go to active acidity as aluminum and hydrogen ions in the soil solution. Pero bakit nga ba importante ang soil pH? Why it is significant? Number one is because it affects availability of plant nutrients. So you can see here, we have above, we have strongly acid, medium acid, slightly, until you reach strongly alkaline. And down at the bottom, you can find the pH level. So we have here, at the left, you have 4, and the middle around 7, and then at the right, we have the 10. Look at first at the nitrogen. So you see, when you look at the pH at 4, wala kang halos makitang puti na side. So most of the nitrogen are not available when your pH is around 4. But then kung nag-i-increase na yung pH mo from 4, nagiging 4.5, meron ka na yung makikita na medyo puti. Medyo wider na siya. And then when you reach around 5.5, mas dumadami pa siya. So this is how nitrogen is being available. And then when you reach until 8.5, unti-unti na rin siyang bumababa. Hanggang when you reach 10, you don't find any nitrogen. So nitrogen will not be anymore available when your pH is too low, like 4, or when your pH is too high, like 10. When you notice a phosphorus, it has a very, very narrow availability. So you see here, from pH of 6, hindi siya ganun kadami, hindi siya available. And then, the peak is around from pH 6.5 until 7.5. But from 7.5 to 8.5, unti-unti siyang bumababa, nagiging konti, and then it will be again available from 8.5 until higher than 8.5. When you look at potassium, halos constant yung potassium. So there's a lot of potassium in the soil. At any pH, you can always find potassium except dun sa extremely strongly acid na yung lupa mo. And then we also have sulfur, we also have calcium, we have magnesium, and look, iron, manganese, boron, copper, and zinc. They are mostly available when the pH is acidic. So, ito ang mangyayari pag ang lupa natin ay acidic. Most of the basic cations in which the plants needs a lot will not be much available. So what is more soluble and available when the soil is pH are the iron, the manganese, boron, copper, and zinc. But remember, these elements, the plants doesn't need much of them. They need it in trace amounts. Kukunti lang yung kailangan ng plants ng mga elements na to. So ang nangyayari, kasi acidic yung lupa mo, these micronutrients, the iron, manganese, boron, copper, and zinc are highly soluble and available. They become toxic now to the plants. That's why it's not anymore good for the plants. Samantalang kulang naman ngayon yung calcium, magnesium, potassium, at saka other elements. So this is one of the effect of pH. That's why it's very, very important because it determines the availability of plant nutrients. As a summary, nitrogen decreases at pH lower than 5.5. Calcium and magnesium decreases at pH lower than 6. Phosphorus decreases at pH lower than 6 and pH greater than 7. And the maximum availability of phosphorus occurs at narrow pH range. The potassium decreases at pH less than 6. Sulfur decreases at pH less than 5.5. Molybdenum decreases at pH less than 6.5. The boron decreases at pH less than 5 and pH greater than 7. And the iron, manganese, and zinc decreases at pH 5. And at pH less than 5, their concentrations are usually toxic. So at pH 5, less than 5.5, exchangeable aluminum becomes available. They are soluble and is a major toxic factor for plant growth because most of the plants, they don't need much aluminum. At pH 4, soil is largely saturated with exchangeable aluminum. The amount of the exchangeable bases decreases as acidity increases due to their displacement from exchange sites by hydrogen and subsequent losses through leaching due to the increase in solubility of compounds bearing iron, manganese, zinc, copper, and cobalt. Thus, the optimal or ideal pH is 6.5 for most crops. Mostly, phosphorus is being fixed at extremely soil acidity or soil alkalinity. So, yun yung nagiging problema pag yung lupa natin is either strongly acidic or strongly alkaline. The second importance of pH is that it affects microbial activity related to organic matter decomposition. Fungi, their growth is not affected by pH level, but the bacteria and actinomycetes or actinomycetes, their growth is inhibited when your pH is around 5.5. And these microorganisms have also functions in the soil, so they are the source of the decomposition of organic matter. So we also need them in the soil. We also have the buffering capacity, which is the capacity or ability of the soil to resist abrupt change in pH. So when the hydrogen in the soil solution, the active acidity is neutralized by lime, hydrogen in the exchange sites, the reserve acidity, moves out to replace the neutralized hydrogen. And the buffering capacity is high if the CEC is high, the clay content is high, and the organic matter is high. So the buffering capacity has a direct effect with the CEC, with the clay content, and organic matter content. So how are we going to manage soil acidity? Number one is we reduce or prevent acidification. How are we going to reduce? How are we going to do it? First, we minimize the long-term use of acidifying fertilizers if possible. You can rotate, or you can, for example, every month ka nag-a-apply ng ammonium sulfate. No, you have to change. Maybe this month you apply ammonium sulfate, the following month you apply urea or other sources of nitrogen, or maybe organic matter. So second is, you reduce the leaching of nitrogen through split application of nitrogen fertilizers. Example lang to ha. In case gusto mo mag-apply na, you need to apply a fertilizer to your plants, and the recommendation calls for 1 kilo per tree of ammonium sulfate or urea per tree per quarter. Dahil gusto mo magtipid, so instead na, pareho lang naman to, 4 kilos per year, i-apply ko na yung 4 kilos in one time. So, sayang kasi most of those nutrients will not be taken up by the plants because sa sobrang dami niya in one time, malileach lang yung ibang mga elements doon. So, sasayang lang siya. So, you reduce the leaching of nitrogen through split application. I-split mo siya, hahatiin mo siya ngayon. So, i-interval mo yung pag-apply para hindi ganun siya bilis maglileach siya sa lupa. And return plant material to the soil. This is the first strategy. Second is, you plant acid-tolerant crops. If your soil is acidic, then you try to choose crops which can grow to your soil. So, although it will not correct the acidity of the soil, planting crops that can tolerate acid soils like sweet potato, radish, pineapple, coffee, and tomato can continue farms' crop production. And meaning, meron ka pa ring income kahit yung lupa mo is acidic. The third one is apply more nutrients, because additional fertilizers can supply the nutrients needed by the crop which are not adequate when the soil is acidic. Remember, every time that we harvest crops, every time na nag-harvest tayo, we also remove a lot of nutrients from the soil through the crops na hinarvest natin. So we need to sustain it, we need to maintain the fertility of the soil by adding fertilizers. It can be organic or it can be inorganic. Number 4 is application of agricultural lime. Of course, when your soil is acidic, you need to apply lime so that we can correct the acidity of the soil. But it will be an additional cost, so you really have to calculate whether is it really necessary and how much really lime do you need to apply so that you can correct the acidity of your soil. So check the economic benefit of lime application. We mentioned lime. Ano nga ba ang lime? Lime is a material added to raise the pH of the soil. The amount of lime added to the soil to get the desired pH change depends on the CEC of the soil, the initial pH, and the type of lime that you are going to apply. Why acid soil should be lime? Because generally, it is difficult to produce high yields of crops on acidic soils because most of the elements, most of the nutrients will not be available, will not be soluble if your pH is low and your soil is acidic. Like potassium and other micronutrients such as zinc, boron, and copper may be low for strongly acidic soils. And even the application of NPK alone would not be a sufficient strategy to increase production, as nutrients may not be available for plants' use. Thus, there is a need to apply the right amount and the kind of lime to solve this problem and to make the nutrients readily available to plants. So as I've mentioned, we use lime to increase the pH of the soil. And most of the lime materials contains calcium and or magnesium to neutralize soil acidity, or oxide hydroxide, or carbonates of calcium or magnesium. So we have two types of lime. We have the carbonate form and we have the oxides and hydroxide forms. A calcium carbonate, it is calcitic lime or calcic lime. It only contains calcium. But then when you apply dolomite contains both calcium, and magnesium in carbonate form. Then we also have oxides and hydroxide forms. We have the calcium oxide, which is the burnt lime, and the calcium hydroxide, which is the hydrated lime. Saan ba makikita natin ang lime? Where do we get them? We're very lucky because Philippines has a lot of lime deposits, especially the islands. Yung mga islands natin, like this picture was taken in Palawan. Oh no, I would not dream to put a quarry there of limestone. Kasi we are going to destroy the beauty of the area. No. But then in some areas, like this second picture is of limestone quarry in Cebu. A lot of the mountains in Cebu are being used for quarry for limestone, and that's why Cebu is also very very prone for floods and erosion. Kasi masyadong na-exploit na din yung ibang resources nila, so nasisira na rin. Kung minsan kasi when we overexploit the area, of course, too much of something is not good. So, kaya isa na rin siya sa problema ngayon ng Cebu. And that's why they have an action there to stop all quarry sites in Cebu City so that they can prevent any other tragedy that can happen. And these are some examples of limes. In Shopee, I took the photo from Google. These are agricultural lime, apog. You can also find them in Shopee, or I think there's a lot. And ito yung kanyang texture, para siyang pulbo. Very very fine. Yung iba naman medyo bato-bato pa siya. So these are some examples of lime that are available in the Philippines. So we have here the commercial name, the burnt lime or the quick lime, which has a chemical composition of calcium oxide. And we have here the CCE or the RNV, which is the calcium carbonate equivalent or the relative neutralizing value. This is the capacity of the material to neutralize salt acidity relative to that of pure calcium carbonate. And then we also have hydrated lime, which is a calcium hydroxide. And we have the dolomite limestone, which contains both calcium and magnesium, and the calcitic limestone, which contains calcium in carbonate form. So these dolomite and calcite are in carbonate form. The burnt lime or quick lime or hydrated lime are in hydroxide or oxide form. What are the factors affecting the effectivity of the lime? First is form and the kind of lime. The reactivity of the lime is in this order. So we have here calcium oxide. We know that calcium oxide is burnt lime or quick lime. Quick, mabilisan. Calcium oxide reacts faster than the calcium hydroxide. The calcium hydroxide reacts more than the dolomite, and the dolomite reacts more than the calcium carbonate or the calcitic lime. And the second factor is the size particles. The smaller the particles, ibig sabihin na pino, or the finer the particles, the more reactive is the lime. The more siya na mabilis yung kanyang epekto. Should be fine. Pag bumili ka ng mga lime, apog na bato-bato pa siya, hindi siya ganun kaganda yung kanyang quality. It has to be fine so that it will react faster. Has a direct effect to your pH. Kasi pag medyo bato pa yan, you still need time para siya ma-dissolve, para siya maging maliliit. So it will take time. So dapat pag bibili ka ng lime, it has to be fine. Then we have the lime requirement. This is the amount of liming material required to raise the pH level to a desired level, and it is determined by the required change in pH. Gaano ba kalaki or gaano ba kataas na pH yung gusto mong ma-achieve? The texture of your soil, because the finer the texture, the higher the CEC, and the greater buffering capacity of the soil. And which crops do you have to plant? Kasi different crops has also different soil pH requirement. May mga tanim na gusto nila ng ganitong pH. sila gustong tumubo. Meron namang iba na gusto nila ng medyo acidic yung kanyang lupa na pagtataniman. So you have to consider them when you are going to calculate your lime requirement. What are the effects of lime in the soil? We have there 3 effects: physical, chemical, and the biological. So with the physical, the application of lime increased the granulation because calcium favors flocculation, but the effect is largely indirect due to favorable effect on organisms which decompose organic matter. We also have chemical effect in which it neutralizes the hydrogen ions, thereby increasing the availability of phosphorus, molybdenum, calcium, potassium, and reduce the solubility and toxicity of iron, aluminum, and manganese. And the biological effect is that it promotes activity of microorganisms such as those that decompose organic matter. It mineralizes nutrients and fixes nitrogen through symbiotically, and however, it can also encourage potato scab. But ano ang mangyayari pag nag-overlime tayo? Masyadong maraming lime yung in-apply natin. Pasobra tayo ng pag-apply ng lime. Remember, too much of something is not good, and overliming could also have harmful effects. It will result to decreased availability and development of deficiency of iron, manganese, copper, zinc, phosphorus, and boron. It could trigger potassium and magnesium deficiency due to antagonism between calcium, magnesium, and potassium. Meron yung mga antagonism, guys, pag medyo marami yung isang nutrient mo, like for example, masyadong mataas yung potassium mo, your magnesium level could not increase. Meron siyang antagonistic effect. Pag masyado namang madami yung magnesium mo, it will inhibit now the availability of potassium. And overliming easily occurs on coarse, textured soils with low organic matter. And of course, you have to remember that mahal ang lime. So that's why you just have to calculate how much lime do you need, kasi sayang din naman pag mag-a-apply ka ng lime na hindi naman pala siya kailangan. And we now discuss the problem soils. These are alkaline and salt-affected soils. Alkaline and salt-affected soils generally occurs in arid and semi-arid regions where the evapotranspiration greatly exceeds precipitation. Masyadong mainit na mga lugar, like for example, Middle East. So, masyadong mataas yung kanyang evapotranspiration kumpara sa ulan. So, very dry yung lupa. The water from rain is insufficient to leach the base cations that are released from the weathering of rocks and minerals. So what are the sources of soil alkalinity? The base forming cations, remember? The base are the calcium, magnesium, sodium, and the potassium, basic cations. As the basic cations such as the calcium, magnesium, potassium, and sodium saturates the soil exchange complex, the hydrogen ion concentration in the soil solution will decrease and the concentration of hydroxide increases. An alkaline reaction results from the hydrolysis of colloids saturated with basic cations. So for example, here sodium reacts with water. It will produce hydrogen, sodium, and also hydroxide. Of course, we also have the carbonates and the bicarbonates. And we also have the saline and sodic soils. What is sodic soils? Sodic soils are soils that have more than 15% of their cation exchange sites are occupied by sodium ions. And their pH is greater than 8.5. And the soil is highly dispersed, masyadong buhaghag, masyadong dispersed, because sodium favors dispersion while calcium favors flocculation. So dispersed humus carried upward by capillary gives the soil black color, which is referred to as black alkali. So how do we reclaim or how do we manage sodic soils? Kasi masyadong madami yung kanyang sodium, sodic. So we need to replace the excess sodium on the exchange sites by calcium. And we need to leach those exchange sodium out of the root zone. So how are we going to replace the sodium? Through the application of gypsum. Gypsum is calcium sulfate, so it is a good source of calcium and sulfate. So gypsum is the cheapest and most commonly used to reclaim soils that has a lot of sodium in the exchangeable sites. The sulfur is likely to be used when the soil contains free lime in addition to too much sodium. Addition of OM is also beneficial, and deep plowing is also good so that you will mix the soil. And we also have the saline soils. Saline soils are soils whose concentration of soluble salts is high enough to hamper plant growth. Remember, in the sodic, we only focus on sodium. But here in the saline soils, it focuses now on salts. It doesn't matter if it's sodium or it doesn't but it's salts. Salts are mostly chlorides and sulfates of sodium, calcium, and magnesium. The pH is usually less than 8.5 and sometimes called white alkali. And there is a specific toxicities due to high concentration of sodium, chloride, and others. And the plant growth is reduced due to osmotic effects. So the plants cannot grow much good if your soil is saline. Masyadong maalat yung lupa. So how do we reclaim saline soils? We can also do that by leaching the excess salts out of the root zone through internal and surface drainage so that all of the salts will be removed. And the retardation of evaporation. So kasi yung salt mo is nandun sa ilalim ng lupa, through evaporation, pag masyadong mainit yung area mo, like for example in the desert, most of the salts that is coming from the lower ground, naangat niya pataas. So yung salt na nasa ilalim ng lupa, through evapotranspiration, kina-attract niya na pumunta siya dun sa taas until it reaches now the roots ng mga plants mo. And because of those salts, your plants cannot grow properly. So, one of the reasons is we need to leach the excess salt. So, pababain natin yung mga salt na yun para hindi siya pumunta sa pataas ng where the roots are located. And we need to retard the evaporation. I-reduce natin yung evaporation by the use of surface mulch para hindi ganun kainit yung lupa. So, hindi ma-attract pataas yung mga salts. And also use of salt-tolerant crops and use of special planting procedures that minimize salt accumulation around the seed and around the roots of the plants. So the saline sodic soils have high level of soluble salts and exchangeable sodium. Soil amendment must first be applied before leaching, and leaching without the amendment will only convert saline sodic into sodic soils. So we need to apply anything, maybe gypsum or maybe organic matter, anything, before we leach the soil. So as a short summary, we have here the different problem solved. So we have saline, sodic, and saline, sodic. So we have here the EC, which is the electrical conductivity, the ESP, which is the exchangeable sodium percentage, and we have the SAR, which is the sodium adsorption ratio. So you see, saline has greater than 4 EC, sodic is less than 4, saline sodic is greater than 4. And the ESP is, saline is less than 15, sodic and saline sodic is greater than 15 ESP. The pH is less than 8.5 for saline, greater than 8.5 for sodic, and saline sodic is less than 8.5, and the sodium adsorption ratio is less than 13 for saline, and sodic and saline sodic is greater than 30. Now, what happened when our soil is flooded? Like paddy soil, the one where we plant our rice, where the soil is oversaturated. Oh, that's wrong spelling, guys. The soil is oversaturated with water.
So the amount of water in the soil has a direct impact on both inorganic and microbial reactions that change the redox potential, acidity, alkalinity, and salinity of the soil. When soil is flooded, the presence of oxygen is limited, and any remaining oxygen is quickly used up via aerobic respiration, resulting to employment of additional chemicals as electron acceptors to get energy, allowing microbes that specialize in this reaction to thrive, which has an effect on the ecosystem nutrient cycling. So when the soil is flooded, the oxygen is depleted after submergence, and it results to the aerobic organisms to die or become dormant. And these organisms are replaced by microorganisms that can live without oxygen. Siyempre, may mga tayo nga, can we live without oxygen? So same also for the microorganisms present in the soil. They need oxygen, and when the soil is saturated with water, meaning walang oxygen, so hindi na makakahinga yung ibang mga microorganisms. So some of the microorganisms will die, mamamatay siya, and some will stay as dormant. And yung mabubuhay doon are microorganisms that doesn't need oxygen. So we have two organisms, like the facultative anaerobes, they can live with or without oxygen. And we also have obligate anaerobes, which can only live with the absence of oxygen. Bacteria mostly survives in anaerobic condition, and some aerobic organisms continue living in the aerobic areas of submersion, sa mga border, dun sa mga malapit na sa lupa. And the aerated soil contains a lot of different organisms and microorganisms which are involved in the composition. And in submerged soils, these aerobic organisms are replaced by anaerobic organisms. And through respiration, it causes chemical compounds other than oxygen to be reduced. This change in chemical compounds result to changes in soil color, soil pH, and the availability of nutrients for plants. The electrons from organic matter in soil are accepted by nitrate instead of oxygen, and nitrogen in nitrate is reduced, and the nitrogen compound becomes nitrogen gas. And the hydrogen ions react with oxygen from nitrate to produce water. So there's a lot of reactions happening when your soil is flooded or oversaturated. And this is from Agri. The submergence of soil typically causes a shift towards a more neutral soil pH due to the change in chemical compound when the soil is reduced. Typical pH range for many submerged soils is 6.5 to 7. And at this, when the soil is submerged, the nutrients that are needed for rice, especially rice, are collectively more available at 6.5 to 7 compared to more acidic or basic pH values. Then I also included the methods of determining lime requirement of soils, particularly VAGE, as requested by one of our students. I will try my best to explain the VAGE method because I haven't encountered VAGE when I was studying in my college days. I just encountered VAGE from my friend when we were working, in-explain niya sa akin kung ano yung VAGE method. So there are different methods in determining lime requirements of soil. The number one is the VAGE method, which is the addition of increasing amount of calcium hydroxide to the soil samples, allowing them to stand for 30 minutes and their pH would be determined. Second is the calcium carbonate incubation in the lab. The third one is the field or pot lime trials. This is the one that we usually do while I was working. We do some tests. We have one soil and we try different kinds of lime rates or different kinds of lime, and we will see what is the effect of that application, those treatments to the soil that we wanted to test. And then the other one is the exchangeable aluminum index method. And the fifth one is the aluminum saturation method. To calculate the lime requirement using the VH method, we have here a formula. So you just multiply the normality of the solution times the amount of calcium hydroxide that you determine times the gram of the soil. We have a sample problem. Calculate the amount of calcium carbonate needed to raise the pH of a soil from 5.5 to pH 6.5 using the result of the following table. So meron na tayo ditong mga amount ng calcium hydroxide that was determined with their corresponding pH. So first, we need to do interpolation. Since alam natin na yung at 20 milliliter of calcium hydroxide, we got there a pH of 6.8. And then we also have a value of 10 milliliter of calcium hydroxide as 6.4. But we want to know what is the amount of calcium hydroxide at pH of 6.5. No? So, nasa in-between siya ngayon ng 10 to 20. So, we have here the solution. 20 minus 10 divided by 6.8 minus 6.4. And we are trying to find the value of x minus 10. So, we have here 6.5. Because 6.5, we are trying to look for the value of 6.5. And then we have here the value of 10 for the 6.4. So 20 minus 10 equals 10 divided by 0.4 is equals to x minus 10 divided by 0.1. Finding the value of x, following the solution, following the formula, we are going to get there a value of x of 12.5 milliliter. Calcium hydroxide will give us a result of pH of 6.5. And then after that, we are going to calculate the milli-equivalent of calcium hydroxide to calcium carbonate. So the formula there is the normality of calcium hydroxide times the volume or amount of calcium hydroxide times 10 per 100 gram of soil. So with that, we just multiply the 0.4 normality times the 12.5 milliliter times 10. So the volume of calcium hydroxide to reach pH of 6.5 is 12.5 milliliter, and 10 will be multiplied for milli-equivalent is for every 100 gram of soil. And then to calculate the milli-equivalence of calcium carbonate, remember in the last video about ion exchange and salt colloids, 1 milli-equivalent is equal to the molecular weight divided by the valence times 1000. So in this case, the molecular weight of calcium carbonate is 100 gram. Why? Because calcium is 40, carbon is 12, oxygen is 16, but we have 3 oxygen, so it will be around 100. And since the calcium has a charge of 2, the 1 milli-equivalent of calcium carbonate, that will be equal to 100 divided by 2 times 1000, and that is equal to 0.05 milli-equivalent per 100 gram of soil. Now, to calculate the kilogram of lime needed per hectare, so after getting the milli-equivalent, calculate the milli-equivalent weight of calcium carbonate, and to calculate how much lime do we need to buy. For calculation purposes, we just, for easy, para mas madali siya, 1 hectare is equal to 2 million kilogram of soil. So to determine the weight of calcium carbonate, we need to multiply the milli-equivalent of calcium hydroxide, which was, paano ba natin na-calculate yung 5 milli-equivalent? 5 milli-equivalent was calculated by 0.04 times 12.5 times 10 is equal to 5 milli-equivalent. And then times 0.05. Saan natin nakuha yung 0.05 gram? This is the milliequivalent of calcium carbonate. And then, so 5 times 0.05 is equal to 0.25 gram of calcium carbonate per 100 gram of soil times 2 million kilo of soil per hectare. But remember guys, in the left side, we still have there in grams. So we need to convert it first to kilo para same lahat ngayon yung kanyang units. So to convert it to kilo, so we have here 0.00025 kilogram of calcium carbonate per 0.1 kilogram of soil times 2 million. So same na siya lahat ngayon. Kilo na siya ngayon lahat. And that will equal to 5,000 kilogram of calcium carbonate per hectare or 5 tons of calcium carbonate per hectare. Yun. So I hope clear to sa inyo. Para mas marami pang sample, this is also sample calculations and VH method of lime requirement. For the following items, using the VH method of lime requirements, a 25-gram soil was neutralized with 60 milliliter of 0.025 normality calcium hydroxide solution. The first question is, what is the number of milliequivalent of calcium hydroxide that could neutralize the soil acidity? So first, we need to calculate the milliequivalent of calcium hydroxide. So we have here 0.025 normality times the volume, which is 60 milliliter, times 4. Bakit minultiply natin siya by 4? We multiply it to 4 since this data here is a result for only 25 gram of soil. And we know that the milliequivalence is normally expressed per 100 gram of soil. So we multiply it by 4. So if we are going to, so we have here 0.025 times 60 milliliter times 4. Then we have here 6 milliequivalent of calcium hydroxide per 100 gram of soil. So that is the number of milliequivalents of calcium hydroxide. The second question is, how much calcium hydroxide do we need to neutralize the acidity of the soil? So for that, for the solution is to determine the weight of the material, in this case, calcium hydroxide, we just have to multiply the milliequivalence of calcium hydroxide times the weight of calcium hydroxide per milliequivalent. We already got it from the first question. So we have here 6 milliequivalents of calcium hydroxide per 100 gram of soil times the milliequivalence of calcium hydroxide. So in this case, the milliequivalent of calcium hydroxide is calculated as this one. So calcium is 40, oxygen is 16, and hydrogen is 1. And then remember that we have here O and the hydrogen is 2. We have to multiply it by 2. So 40 plus 16 times 2 plus hydrogen times 2 is equal to 74 gram. And since meron tayong valence na 2 from the calcium, then we just divide 74 divided by 2 times 1,000. So 74 divided by 2,000 is equal to 0.037 gram of calcium hydroxide per milliequivalent of calcium. So 6 milliequivalent calcium hydroxide per 100 gram of soil times 0.037 gram, that is a milliequivalent of calcium hydroxide, times 2 million kilogram per hectare. But don't forget guys that we need to, because it's in gram, we need to convert it into kilo. And if you are going to follow it, the formula, it will give you a result of 4.440 kilogram of calcium hydroxide per hectare or 4.4 tons per hectare of calcium hydroxide is needed to neutralize the acidity of the soil. For the third question, how much lime do we need? Lime meaning calcium carbonate, if we're going to use calcium carbonate. how much of lime we need to correct the acidity of the soil. So to calculate it, it's just the same, but then remember, we need now to get the milliequivalents of calcium carbonate. So same pa rin siya. So we have 6 milliequivalent calcium hydroxide times the molecular weight of calcium carbonate, which is the 0.05 gram. Paano natin kinalculate yung 0.05 gram? Same pa rin siya, guys. So calcium carbonate, so we have here calcium is 40 gram, carbon is 12, oxygen is 16, and since meron tayong 3 atoms ng oxygen, it will result to 100 gram. And since we have a valence of 2 from calcium, so 100 divided by 2 times 1,000, so 100 divided by 2,000 is equal to 0.05 gram. So we just multiply the 6 milliequivalents of calcium per hydroxide per 100 gram of soil times 0.05 gram per milliequivalent of calcium carbonate, and it will give us a 0.3 gram of calcium carbonate. But then, since nasa gram pa rin siya, so we have to calculate it into kilo. So magiging 0.0003 kilo calcium carbonate per 0.1 kilogram of soil times 2 million will give us a result of 6,000 kilogram calcium carbonate per hectare, or 6 tons of calcium carbonate per hectare. And then the amount of magnesium oxide, which is 80% pure, that can be used to neutralize the acidity of the above soil. So in this case, same pa rin siya, guys, but then instead of calcium carbonate, we need now to get the molecular weight of the magnesium oxide. For the magnesium oxide, magnesium is 24, oxygen is 16, so it will give us a value of weight of 40 gram. Since magnesium has a valence of 2, so it will be 40 divided by 2 times 1,000 is equal to 0.02 gram. 6 milliequivalent times 0.02 will give us a 0.12 gram. And then you convert it to kilo times the 2 million kilo per hectare will give us a result of 2,400 kilogram magnesium oxide per hectare. But then remember, guys, that magnesium oxide is 80% pure. So, iba siya kumpara dun sa, remember we have seen in the previous slides about the calcium carbonate equivalence or the relative neutralizing value. Calcium carbonate has a RNV or CCE value of 100. And here in this case, we only have 80% of that for the magnesium oxide. So to calculate it, 100 divided by 80 times 100 is 1.25. So don't forget that it has only 80% purity. So we need to calculate 2,400 kilogram per hectare times 1.25. And that will give us a result of 3,000 kilogram magnesium oxide per hectare, or 3 tons magnesium oxide per hectare. So if we use calcium carbonate, we need 6 tons calcium carbonate per hectare. But then if we are going to use magnesium oxide, we are going to use only 3 tons of magnesium oxide per hectare. Bakit mas kukonti na lang ang kailangan natin na magnesium oxide? Because magnesium oxide is a burned magnesite, and this is derived from heating magnesite and contains about 50% magnesium. And its neutralizing value is higher compared to calcium carbonate. So the calcium carbonate is around 100 neutralizing value, samantalang ang magnesium oxide has a range of 180 to 220 relative neutralizing value. Kaya mas kukonti na lang ngayon ang kailangan natin na magnesium oxide compared to calcium carbonate. I hope nakatulong to sa inyo, guys, yung presentation na to. Meron kayong na dagdag na kaalaman about pH, soil pH, and the lime requirement, to calculate the lime requirement. And the next presentation will be about fertility and fertilizers. Short version kasi nga kulang na tayo sa oras. So I hope makahabol pa to yung presentation na to for your preparation before kayo makapag-take ng board exam. So thank you very much. And if you are new to my channel, please click the subscribe button and it will help me a lot. And you can also share this video to your friends. Thank you and see you next time. Bye!